Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.
Hey, math lovers, let's go over this Module 8 test, 8.1 to 8.5, taken October 1st, 2021. Matching retail. Shop owner operates a retail store and website. She wants to survey her current customers about potential items to sell. Match each study to its sampling method. What are the sampling methods? Here they are on the sides. I'm just going to write a quick definition of each of these. So stratified means similar groups. Convenience means whatever is the easiest, right? Where I say whatever student walked in the door. Systematic means some kind of like every third person. And self-selected is another word for volunteer. So as we read these, let's go ahead and go through these. A, the shop owner splits the customers into 4 groups based on their location. Okay. And then randomly selects 30 people from each group. Okay, so, I'm thinking of different locations. I'm thinking like Fullerton, people from Anaheim, maybe people from Orange, and people from like Buena Park, right? Those are the different locations, and so they're grouped by similar groups. That would be A. B, the shop owner surveys every 10th customer. I see the word every, and that would be systematic. So that would be B. And C, a survey is placed inside every order with a paid postage for customers to complete and return. Well, question, when you guys pick up your food and someone puts like those surveys on their receipts, who does those? Well, it's only people who volunteer. So that would be C. And then D, the shop owner surveys every third customer that comes into the retail shop. I think that's super easy because they're coming to you, you don't do anything. So that would be D. Question number 2, which is an example of a biased? Let's circle that word, biased. Survey or question. Bias means someone kind of pushes you or helps you lean towards a certain direction or push you. That's my definition. So, A, do you agree that very unhealthy sugary beverages should be illegal to sell? Well, were they asking that should be illegal? Now they're telling us like, wow, these things are unhealthy and they're sugary and give you diabetes. Well, that definitely sounds biased to me. Let's talk about B. What subject are you interested in studying more? That seems very unbiased. It just seems like more like a yes or no. That's a good, in our case, that would be unbiased. Do you think the school should allow community members to use the workout room for free? I think that's an unbiased, it's just a fact question. Facts, right? And same thing, how many calories did you eat today? It's just facts. So A is your correct answer. Make that darker. Multiple choice. Research. A researcher wants to determine how long a child might play with a new toy. Okay, what does this person do? She observes the 120 children playing with the toy and marks the time the children stop playing with the toy. The study of this type was it a survey, experiment, or observational? Survey, you give them something. Experiment is you do it, and sometimes you compare 2 groups. And observation just means you watch. Right? You go to a really tall building and they have something called an observation tower. You just watch what's out there. And that would be the answer, C. Number 4. Researchers are testing different prototypes for new cell phones. Each randomly selected participant could choose one of 4 types of phone. The researchers observed the number of people that selected each type and the positive reactions. The results are shown. Okay, so they're just, I said, here's 4 phones, take a look at them, and then pick it up, and then tell me if you like it or not, like a positive, right? So write a conclusion from the results of the study. Phones blank and blank were chosen the most. Okay, which one was chosen the most? That would be these two, right? So that would be C and D. They were chosen more often than what? What were the other two choices? Well, that would be A and B. Of the participants that chose phone C, so participants that chose phone C, most had a positive experience. Based on the phones chosen the most, so that's between C and D, phone blank did not have a positive experience. So that would be, I think, D right there. So based on the phones chosen the most, which one did not have a positive or which one had a negative reaction? Okay, question number 5. A spinner is divided equally into 4 sections. So you can draw a picture. I got red, yellow, blue, and green. It's spun 50 times, and the results are recorded in the table below. The theoretical probability is, well, remember, theoretical means in theory. What should happen? Well, there's a total of 4 colors, and we are picking 1. So this should happen 25% of the time. The experimental is basically what happens. So we already know that this is equal to 50, and red is 10. So that would be 20 out of 100, right? You can just double it. And anything out of 100 is a percent, so that would be 20%. So that means red came up less because it should be 25%. Okay? Question number 6 was left blank intentionally. Question number 7. A high school principal claims that 25% of the school lunches purchased do not include a fruit or vegetable. Which simulation can accurately test the claim? Okay, simulation is just kind of like a computer prediction. Computer prediction of what will happen, right? They do a weather simulations. Will the hurricane reach the city? Okay, so I just want to talk about the 25%, the principal's claim. Remember, it's a percent is out of 100. Okay, so let's read each of these situations. A, use a fair die with 1 representing a lunch without fruit, and 2 to 6 lunches. The numbers 2 to 6 represent lunches that do have. So this would only be 1/6. Now 1/6 is not the same as 25 over 100 or 25%. 1/6 is 16.67%. So not that one. Okay. Let's try B. Use a random generator with the numbers 1 to 25, where 25 represents a lunch without a fruit or vegetable. Okay. You might be tempted to pick this one because you see the word 25 and you think 25. But it says 1 through 25, so there's 25 numbers, and only one number, what number is that? 25 has a lunch. So if you multiply that by 4, an equivalent fraction is 4 out of 100, or 4%. So that is not ours. Okay, so use a spinner with 4 equally sized sections colored red, blue, yellow, green, just like we did above, and red represents a lunch sold without fruit or vegetables. So that would be 1/4, and 1/4 is 25%. So that one matches. And then the last one, use a fair coin. So a coin has how many sides? Where the heads represents a lunch without a fruit or vegetable, and tails represents a lunch with fruit or vegetables. So there's 2 choices out of the coin, and we're picking 1, so that would only be 0.50 or 50%. So not that one, so our answer is going to be B. Number 8. Consider the information from question number 7 above. In a 100 simulation of 100 trials, results likely showed how many lunches purchased without a fruit or vegetable. Well, if you do 100, that becomes my denominator. And 25% is just 25 out of 100. So I'm trying to find a number that's 25. And that would be under choice C. We would expect it between 22 and 27. Question number 9. Calculate the standard deviation for the set of data 22, 20, 24, 20, and 24. Tell you my calculator commands. You could also do this by hand. I'm going to go stat, edit, list 1, stat, calc, and then number 1, and then 1 var stats. Okay? So let's go ahead and do that. So stat, right next to the left key, edit. I'm going to go up here, clear it, press enter, put in my numbers, 22, 20, 24, 20, and 24. I'm going to press stat, calc, number 1, 1 var stats. The default is list 1. If you put in a different list, you have to put in the number L, whatever you put your list in. And then we're looking here for where it looks like an SOCS. That would be the population standard deviation. And that would be choice 1.79, which would be A. So, all right, question 10, intentionally left blank. Number 11, Kelly sells items at craft shows. Each year she attends the same craft shows and keeps track of the number of items she sells at each. The results are shown. On average, Kelly sold more items in... Okay, so on average, so this is the word mean, or the symbol we're going to look for is X bar. Okay, so I'm going to call this one the green group. And then down here, where it says number of items were sold and more varied, is called the standard deviation. In this case, we're going to look for the population standard deviation, which is going to look like that. And I'm going to call this one the blue in 2017. Okay, so let's go ahead and punch those into our calculator. Stat, edit, and go up to 1 and press clear. And you can go up to, I don't have it in there, 2, press clear, and I'm just going to enter the numbers, 48, 32, 26, 35, 18, 25, 32. And let's go ahead and get those numbers. Stat, calc, 1 of our stats. And there I have X bar there. The average is 27. Take out my phone, take a picture. Okay, let's do the same thing for stat, calc, 1 of our stats. Whoops, stat, edit. List 2, down. 40, 42, 38, 39, 35, 34, 45, 42. So I'm going to press stat, calc, 1 var stats, and then I'm going to put in list 2. So second, number 2. And those are my numbers. Let me go ahead and take a picture of this. Okay, now I'm just going to go back. So in green, my average was 27, and my standard deviation was 9.55. And then the second list, in blue, I have 39.375, and my standard deviation also 3.46. So which one has more for A? 27 or 39? 39, so that would be the blue one here. And number of items that are sold that are more varied or greater standard deviation, which one has a bigger number, 9 or 3? That would be 9, so that would be choice A. 12 lying intentionally, and then number 13. Classify the variables as discrete. So this one is where you count, think of like eggs in a carton. And then continuous basically means you have decimals. Like how fast did you run that race? You might get 1 minute, 7 seconds, 9 minutes, 27 seconds. It could be decimals as well. Okay, scores in a football game, well, that would be discrete, right? It's just like 1, 3, 7, they're counting numbers. 3B, the number of people at a movie theater, same thing, that is discrete. You can't have 13.2. And then C, age of a building, you can have decimals because you might have like 14 years and 2 months. Well, you can change 2 months to over 12 months and get a decimal. So that would be continuous. Number 14. Which value is represented by B on the image? So here's B. And notice there you have 2 standard deviations. So that is called the empirical rule. And the empirical rule is 68, 95, and 99.7%. And that represents 1 standard deviation, 2, and 3 standard deviations. So it says the mean plus 2 standard deviations. And this idea here would represent 95% of our data. So C. Number 15, a normal distribution has a mean of 26. So remember, the mean is an average, but it's also called a measure of center. Let's go ahead and do it up here. I'm going to draw my normal curve. There's my center. And I'm going to put in here 26. Okay, and then standard deviation. Here I'm going to add 1 standard deviation. We're going to add 2 standard deviations, and that's plus 3 standard deviations. And this is just subtracting. Well, if the standard deviation is 5, you're just adding 5 here. 2 standard deviations, so 2 times 5 would give me plus 10, and this would be plus 15. And then you're just subtracting here. So that would represent 26 plus 5, which is 31. 26 plus 10 is 36. And then 26 plus 15 gives me 41. And then 26 minus 5 is 21. Minus 10, no, not minus 10 from 21, but minus 10 from 26, which gives you 16. And then minus 15 from 26 would give you 11. So if you recognize that the red numbers are essentially just counting by 5, which is the standard deviation. Okay? Okay, so if I do the first one, 21 to 31 here, so that represents how many standard deviations? 1 standard deviation away, which is 68%. And then 16 to 36 is here. So that represents 2 standard deviations away. They would want to know that. So again, that would be 95%. All right, number 16. Almost done there. What is the value of z? So the formula we have here is z equals x minus the mean over the standard deviation, and you just substitute those in. So x is 17. The mean is 5. And the standard deviation is 2. So 17 minus 5 is 12, and 12 divided by 2 is 6. So we have a z equals 6 as our answer, and that would be that choice right there. 17 is left intentionally blank, and then number 18. Audrey surveyed 100 customers at her shop. She asked each person how much time they typically spend in a shop each time they visit. The average time was 40 minutes. So let's go ahead and stop and write down some information. N equals 100. The average time was 40 minutes. So I'm going to call that x bar equals 40 with a standard deviation. So I'm going to call this one S equals 10 for this portion. Use a 90% confidence interval to find the maximum error. So I like seeing that word maximum error because I have a formula for that. Maximum error is E equals Z times S divided by square root of N. Okay, so a z-score comes from the 90% confidence interval. And we just had a chart, and z equals 1.645. You could look up the table, but I kind of gave you just those 3 big values. The standard deviation we said was s equals 10. And then the n value we said was 100. So n is 100, and you have to take square root of that. All right, if you simplify this, you'll get 1.645. The square root of 100 is actually just 10. And 10 divided by 10 is just 1. So you're just left with 1.645, which would be choice A. Number 19. Which formula can be used to calculate the maximum error of the estimate of the population proportion? So in this case, you need one like, remember, p hat equals yes, and then q hat means no, so p hat plus q hat equals 1, right? Yes plus no equals 100% of your decision. And then the formula, the key word here is proportion, so it's not the one above, but it's very similar. E equals z times s over square root of n. That's what we had before. And what's different about this formula is you have the square root of p hat times q hat over the square root of n, and that's going to be, now if they're both in the same radical, you could just say they're both in the same house, which is choice D. Yay, the last one. Number 20, fill in the blank. Parks. A survey of 400 residents, so let's go ahead and write that. And a city asked whether they agreed to build a new city of park. Of those surveyed, 320 agreed with the plan. Okay, I'm going to go ahead and highlight this. So that's kind of like an x value. X equals 320. Use a 95% confidence interval. So we're going to change that to a z-score. The z-score that we need is 1.960. To estimate the population proportion. Round each answer to the nearest hundredth if necessary. Okay, there's a couple things we got to do here, so let's just go ahead and do those. The first thing I need to do is figure out my conditions. Just break this up really quickly. All right, so what are our conditions? We need to know that it is large enough. All right, in order to get p hat is equal to x divided by n. So that would be 320 divided by 400. Our n value is 400. And if you just simplify this really quickly, you'll notice that these will cancel and you're left with 320 is greater than or equal to 5, which is good. Okay, q hat is the complement, so you just take 1 minus p hat. So you can do something like this, 400 over 400 minus 320 over 400, because that's p hat is this number, right? And then you can just subtract, so you'll get 80 over 400. And that makes sense because 320 plus 80 gives you 400. So n is 400, q hat is 80 over 400, and then you should be able to do some simple math here and realize the 400s cancel and you're left with what? 80. And is 80 greater than or equal to 5? That is true. So our conditions are met. The second thing we were supposed to do is calculate p hat and q hat, which we already did. So I'm going to move this over there. I'm just going to erase that line. Whoops, what did I erase? Okay, so second condition, we were trying to figure out success and failure. Which we did. Okay. Step number 3 is we need a critical value. Basically, we're changing it from 95% to a 95% confidence interval to something, a z-score. And the z-score we already said was, looking at our chart, is 1.960. Okay, so that is our z-score. Number 4 I need to figure out the maximum error. And that formula is what we did previously. E equals z over p hat q hat over square root of n. Okay, so z is from up here. So that would be 1.960. Q hat is 320 over 100. Over 400, sorry. And we're going to multiply that by the complement. So, whoops. We left it over here, which is essentially 80 over 400. What? Come back here. So 80 over 400, that is our Q hat, right? And then all that divided by our N value. N value is 400. Okay, let's pop that into the calculator. Okay, so I'm going to do 1.960, and to make a fraction, You can do alpha y equals, where it says fraction, nd numerator denominator, and then I'm going to type in here parentheses second x squared to get my radical, and I'm going to type in 320 divided by 400, close the parentheses, open the parentheses, times 80 divided by 400. Close the parentheses, right key, and no longer is it red, which is good, and I can go down and then type in the square root of 400. Right key out, and then close parentheses. And we'll get 0.0392. Okay, the last step is to actually calculate this interval proportion. I'll just call it interval. And to do that, if you look at your formula sheet, p hat plus or minus the e value. Okay, so 320 divided by 400 is equal to 0.8. So I could use 0.8 plus or minus the e value, which we just found, and now you can separate the plus or minus. So that would be 0.8 plus 0.0392 and 0.8 minus 0.0392. And you're going to get two values, 0.8392 and 0.7608. And you can, what does it say? Round to the nearest percent. Round each percent to the nearest hundredth. So this one I would round to 0.84 and 0.76. So multiply two decimal places. So 76 to 84 would be our answers. And that's going over the Module 8 test. We'll see you guys later. Bye.
Shout out to Mr. Ng for being the best math teacher that there is. And math is easy.